Hello everyone, this video is going to explain the usage of code graph. In this video, I would like to use my own project to explain the basic usages. So now we can see there is a solution here, and I have installed the code graph Visual Studio extension. Now the first step, I would like to open the code graph window. So now I have the interface of code graph, but it's empty. The next step is I should analyze the solution. Just click on this button. So now we see there is a console, a black window here showing some messages. So it's actually Doxygen. The reason that Doxygen appears here is that code graph actually use Doxygen to generate a bunch of data files and then read those files and show it in this interface. So now we have finished analyze, and those data files are generated, but the interface is still empty. So now what we can do, and actually I see a lot of users just get stuck here. They don't know what to do next. The answer is just click a function or a class here and then press Alt plus F. So you can see there is a small disk showing in the interface, and this disk represents this function. And if I want to show a class, I can just click on the class name and then plus Alt plus F. Or you can do the same thing using menu commands like showing graph. So let me click another name, showing graph. Yeah. So let me magnify the interface. You can use the mouse wheel to magnify the user interface here, the viewport here. So now we can see different symbols like classes or functions are actually represented by different shapes. For example, this disk with two fans on the left and right hand side represents a function, and the size of the fan on the left side represents the number of callers of these functions. That means how many functions are actually calling this function. And the fan on the right hand side represents how many functions this function is calling. So represents the number of callees of this function. So this is functions. And the diamond shape represents a class. And then we have functions and class, but what we need is not a single symbol but a graph. The next step is we should dig out the graph from the symbols we show at the very beginning. So let's say if I want to show the callers of this function, get, normal, and def, what should I do? I just press Alt plus C, and you can actually see the commands here. Yeah, Alt plus C. Or you can actually do it in the just right click on the symbol and do it in the corners menu here. And then when I want to show the callees of this function, I just right click it and press this. So there are actually 2 colors and 1 colors. And look at this symbol. So this symbol with a triangular shape is a variable. So it shows this function is using this variable. And I can actually show more variables by clicking Alt plus V repeatedly, or I can just use the context menu here. Yeah. So now that we can show colors and colors, but sometimes we cannot just show that. The reason is the capability of Doxygen is limited. That means sometimes it just cannot detect the colors or colors for a function. For example, for this function, let me double click on the symbol of this function, and then the editor will jump to the code place of this function. But as you can see, there is no any fan on the left hand side. That means there is no colors detected by the Doxygen. But that doesn't mean there isn't any colors here. Sometimes it's just because Doxygen failed to detect them. So what can I do if I want to find some colors that Doxygen cannot detect? I just press Alt plus U. As you can see, there are some results from the Find Results window, and there are actually 5 results, and you can see there are 5 arrows showing in the editor. So these 5 green arrows correspond to the 5 results in this window. So there are actually some colors for this function, but they're just not detected by the Doxygen. So let's jump to these colors. Like just double click on the colors. So this is the function itself, it's not actually a color. And then you can also use your keyboard to move the cursor, I mean the symbol highlighted in the viewport. Right? Now I use the mouse, it's okay, but you can also use the keyboard, and sometimes it's more convenient. If you want to move the highlighted symbol by using the keyboard, just press Alt plus K and then moving it down, and Alt plus I moving it up, Alt plus J move left, and Alt plus L by moving it right. As you can see, when you move the symbol, the editor also changed. I mean the contents in the editor also changed. So it's a convenient way to navigate through the graph. So now I want to turn these code places like CPP and 9233 into an actual symbol. I just press Alt plus U again, and then it becomes a function. So this is actually the function that calling the functions we want to find colors. And you can actually double click on the edge here, and the editor will go to the place that this function is calling another function. So you can do this, and then I can do the same thing for another place. Just move to the another green arrow here and press Alt plus U. So it become, so this empty circle means it's an interface. Go on pane. So it's an interface here. And then I do it again. So it's the same interface. Yeah. And then for the last arrow is the function itself. It's also the function itself. So by using these ways, I can actually take out the callers of a function. So this is for callers. The reason that there is a separate hotkey like Alt plus U instead of just Alt plus C is that Alt plus C is just show the results from Doxygen, but Alt plus U just use the functions provided by Visual Studio to show the actual callers. They actually read the results from this window, the find results, and then find the symbols, find the code places listed in these results. Yeah. So let me focus on callees. As I said before, there are some functions that cannot be found. There are some callees that cannot be found by Doxygen. So in this case, you have to find it manually. So the way to do that is to move your cursor into the function you are interested in, and then plus, and then press Alt plus H. As you can see, there is a new function showing in the viewport, and then the editor just jump to the function that you are interested in. So this is for Alt plus H. For example, if I am interested in this function, I just move my cursor to it and press Alt plus H, and then another function just gets shown in the editor. But sometimes even you use Alt plus H, you cannot find a callee, because in some cases even Visual Studio fails to detect that kind of callees. This is the case for some interfaces, because for an interface there may be many different implementations coming from different classes. So it just Visual Studio just cannot just jump to a single place, a single implementation for interface. So if that is the case, you have to establish the edge manually. The way to do that is to show the symbol first, like there is a symbol here, and if Visual Studio just cannot detect the edge for you, you have to do it manually. The way to do it is simple. Just press the middle mouse button here. Move your mouse to the collar, and then press the middle mouse button, and then drag the mouse So you can see there is a edge, there is a curve originating from the functions, and then when I drag the mouse to the coordinates, I am interested in, and then drop the mouse, so there is actually an edge connecting the colors I want and the coordinates I want. So I just establish an edge manually, and you can actually do that for any kinds of symbols. For example, if I think, so for this file, this blue square represents a file. If I think this file is related to this function, I can just do the same thing on this file and establish an edge between this file and this function. So by using all of these techniques, I can actually build up a graph for my own. So now you can see there is a little graph here and showing some caller relations, some function evocation relations, and some file with some relations between the functions and the file. So if I am interested in this graph and I want to save it, what should I do? The way to do that is to use a bookmark. So a bookmark is like a saved graph. The reason you have to save a graph is that the symbols showing in the viewport is limited. You can actually set the maximum item count, maximum symbols showing in the viewport here. So now it can show at most 50 symbols in the viewport. But when I set the amount to 30 or 50, you can actually see some symbols disappear. And yep, so you can only see this function and the whole graph just get lost. So if you want to, you have to save your results after you just take out a graph. The way to save a graph is use the bookmark. Just click on this symbol and then input the name for the graph. Like I want to name this graph as pain workflow, and then press add or replace bookmark here. And you can actually see there is a new tag here, but nothing is actually changed in the graph. And the reason is I actually just add one node, that is this symbol, to the graph, and other edges don't belong to the graph. So I need to add other edges. The edges are interested to the graph. So the way to do that is to choose the edge, and then press Ctrl plus 1. I press Ctrl plus 1 because this is the number one graph, the first graph I add in the editor. So press Ctrl plus 1, and then just add the edge into the number one graph here. And I can actually do the same thing for other edges. And then I can take out more coordinates and do the same thing. And So you can notice that now I just use the keyboard to navigate the graph, and I don't use the mouse at all. So it's actually quite convenient. So let's say as I show more and more symbols in the viewport, some old symbols just disappear. Like if this symbol is just get deleted because there was too many symbols showing in the viewport. And so how can I find the graph I just saved? How can I find this graph? That is to just click on this button, and then you can see this edge and this symbol just come back. So I can actually do the same thing for some colleagues. And if I want to find the class that owns this function, so this function is actually a member function for the Service Painter class. If I want to find a class, I just press Alt plus M, and it will show the symbol here. Or you can just use this command and it will show the class. So now I have the graph, and I want to add another graph showing the members of the Service Painter class, and I call it Painter Members. So I can do the same thing. So I just add this node into the Painter Members class, Painter Members graph, and add the edge to the graph. If I want to add the edge to the graph besides the way I previously mentioned, I can also press the plus button here. Or if I want to add this edge to the first graph, that is Paint Workflow, I just press the plus button here. And you can actually see there are two colors in this edge. One is blue and another is kind of green. So that means this edge belongs to two graphs. And I can actually add more edges. So by pressing Alt plus M, I can show more members for the Service Painter class. And then I just press Ctrl plus 2. Press Ctrl plus 2. Or just choose the edge and press the plus sign here. So this is the way you build up a graph. So as you build up more and more graphs here, this list will just get longer and longer. And actually, I find it quite helpful when you when you want to read some new code in a project, especially large projects, because in that case, the most important information you want to know is the function evocation relationship. So which function evokes which function, and so by digging this kind of relationship, you can know the whole workflow, the control flow of the code. Yeah. And another feature I want to explain is you can actually comment on a symbol. Like I want to write some comments for this function. And then I just choose this symbol and then input my comments in this place, and then press update. And as you can see, there are some green messages appearing here. So this is the comments I just input. So combining these techniques, I can gradually dig out the whole workflow for a project. So this is the main usage, and there are some special cases in which you can't just use the code graph effectively. For example, maybe there are some special files. For example, if you are a graphics programmer, there are some shader files, and those shader files are actually using a language called shading language, which is very similar to C++. But Doxygen just can't recognize those files because they have a different extension instead of CPP. So what can I do for those files? I can actually, for example, there are some GLSL, that means OpenGL shading language here. These are the shader files, but it's not part of the C++ files, so Doxygen just cannot detect these files. Let's say if I want to show this symbol, it's not actually showing the symbol here, it just shows the symbol in the main function. It's not what I want. So to get Doxygen to recognize this file, I have to add a custom extension here. So I just type glsl, that is the extension for this file, and because it's quite similar to C++ or just C, and I just choose the language to be the language that Doxygen consider it is. Sometimes there are some difference between the custom language and the language listed here, but it doesn't matter because in most cases Doxygen can analyze most symbols, just use the rules the semantics and grammar for the language you choose, so it doesn't matter. And then I choose C++ and add custom extension, and then I analyze the solution again. This time the solution will be analyzed from scratch, but these shader files will be considered in the analyzing process. And then after that, you can detect the functions or symbols inside these files, these shader files. Let's say we want to show this file, show the symbols inside this file. So Now you can actually show the symbols inside this shader file, and you can just do the same thing like I just did for those CPP files. So this is for custom files. And there is another thing you can custom is you can actually custom some macros. And sometimes there are some macros defined in the code, but Doxygen just cannot analyze the code inside those macros because it cannot find the definitions of those macros. If that's the case, you can manually define the macros here. For example, if I want to define a macro called macro 1, and the value is 1, I can just write like that, macro 1 equals 1, and then add macro. And next time, and then analyze the solution again. And this macro and its value will be considered during the analyzing process. And if you want even more customizations, let's say these two custom files and custom macro cannot satisfy your needs, you can actually open the Doxygen window here. So in this window, you because it's the window from Doxygen, you can do all kinds of customizations in this window. Yeah, but in most cases, these two customization is enough. And for those huge projects, like there are some software companies, they developed huge softwares. If you just press analyze solution, because I don't think the analyze process will end because there are just too many files, like thousands of files or even tens of thousands of code files. But what you are interested in maybe is just maybe or 20 or 13 or so files. So it's actually a very small portion of the project you are working in. In this case, you don't need to analyze the solution. You can just analyze open files. So in this, if you click this button, Doxygen will only analyze those files you opened in the editor. So that's the case. Yeah. And so this is the basic usage of CodeGraph, and hopefully it can clear some confusion about the usage of the plugin, because I saw lots of the complaint about the usage of it, and they just get stuck in the very first step, and that's quite sometimes it's quite depressing, because the user just go the wrong direction instead of the direction you expect them to go. Yeah, hopefully that will help. Yeah, thank you.